Hi, my name is Jens and I work with game development in our Stockholm studio, and I will talk about spine animations and also how we designed the game using spine animations. Okay, so first off, what is Spine? Spine is a 2D animation tool, most often used by animators on a desktop machine. And it works by creating a skeleton structure with bones, which makes up the object. And these bones can then be animated, so move one part of the skeleton and the rest of the structure would follow. Position, scale, and rotation of the skeleton can have different keyframes, and the runtime will interpolate between those keyframes. When the animation is done, it is exported to a file which can be loaded in code. And one file can contain many different animations. Some pros and cons using Spine. Spine animations uses far less memory and is faster to load compared to sequences or frame-by-frame animations. The animation can be controlled in runtime, for example, speeding up or slowing down while still keeping the animation smooth. It's also easy to jump to specific positions inside the animation. But some types of effects can be tricky to create, so for example explosions. And it's quite hard to create smooth animations when the animations are very long. So I want to show you just a quick side-by-side. Let's see if I can do this. Okay, so here you can see two different animations. The one to the left is using Spine, and the one to the right is using sequences or frame-by-frame animations with spreadsheets. And if I can do this, I slow the animation down a bit. You can see that the Spine animation is still very smooth, but the sequence animation is a bit choppy there. So this is because the spine animation is interpolating between the different keyframes. So when comparing the assets for these two animations, it's clear to see that the image used by Spine is much smaller in size. And the animation to the left is used by Spine, and the image to the right is a sequence. So I also want to show you a short video using Spine.
Spine is a 2D animation tool for games.
All right. Okay, so how does it look when loading a Spine animation with code? So first we load the exported JSON file using the pixie loader. And when loading is completed, we create a new spine animation with that spine data. Then we add the animation to the container and simply play the animation of our choice. So I will talk a bit how we use this to design a stunt jump game. And we'll go through what we wanted to achieve, some possible design solutions we had, our final design choice, a few problems we had along the way, and the result. So what did we want to create? We wanted to create a bonus game that reflects the stunt jumps of a Nitro Circus show. Nitro Circus is a show where the athletes do crazy stunt jump tricks with different vehicles. So, some requirements we had. So all of our slot games are based on math. So the game must be designed in a way that it can accept math as input. It's not a skill game. 7 different vehicles. Each vehicle will have different stats that impact the result of the game. And different vehicles can perform different kinds of tricks, and tricks affect the winnings. Stunt jumps should have item pickups, for example collectibles, speed boosts and multipliers. Also, all of our slot games must be able to be restored and replayed, so this game must be able to handle that as well. And replay means that the player can choose to replay a certain part of a game, and restore is used, for example, if the connection breaks and the player would like to continue where he or she left off. So, another video. So this is an early concept video. Something strange with the sound there, I don't know. Let's close these. Some more concept images. This is an early concept of the stunt jumps on the track. You can also see the item pickups. In the game there's a final big jump where you're supposed to boost and try to land on the multipliers, which will add to your win. This shows the landing on the multipliers. Some concepts for the boost button and the vehicle. And this is early concepts for the different vehicles the player can choose from when playing the game. So we had some possible design solutions for doing this. And one way could be that we would handle all the physics and tricks with code, but that sounds pretty complex. It's not very easy to be based on math as input. We don't also want any bugs where the vehicle would crash when it's not supposed to do that because of something with physics. It's also very hard to create nice looking animations of tricks we don't code. We could have just done the physics and movement in code, but have the tricks animated with spine. Could have worked, as we don't need to create those complex trick animations inside the code, but it's still very scary to do physics in a game that must have reliable results, so we don't want any unpleasant surprises at runtime. We could have done everything in a very long spine animation, but not a very good solution because the jumps and tricks are random, and we would have needed to create very many different animation scenarios for that. And probably the animator would have died creating all of those animations. So, what did we do instead? We ended up creating different animation parts in Spine and glued them together at runtime. This was pretty good because we can reuse animations. We can also put the parts together in any order that we want. That can easily be changed later. This is some examples of the different parts that was created. A, just a straight track, can be used for creating never-ending tracks by just adding one animation after another. B and C, stunt jumps with different item layouts. And we created many of these with different trick animations. And D, the final big jump and the multiplier landings. And when putting the parts together, we just place the spine animation next to each other with code. So in this example, we put the straight part A with the stunt jump part B right after. All animation parts have two different states, on and off. It's on when the vehicle is currently driving in that animation, and off when it's not driving in that animation. At the right time, when the current animation is about to come to its end, we switch those states. So this will look like the animation just one big, long animation, not constructed of different parts. To improve performance, we only have 3 different animation parts at any given time. But the total length of the track is much longer than 3 parts. So we need to move the spine animation parts along the track while the vehicle is moving. The layout of the item pickups are created inside the spine editor tool. And at runtime, these items are switched to the real items that comes from the math of the game. This is quite easy to do because the position of the items can be found at runtime by finding the name of the object inside that spine animation. We also did camera tracking. And the camera tracking works by moving the spine animations in the opposite direction of the vehicle. So when a vehicle drives right, we move the spine animations to the left. We also use camera lagging and camera panning. And camera lagging is when the camera is lagging behind the vehicle to make the camera movement more smooth, lerping between current camera position and vehicle. And lerp is about moving from one point to another with a smooth step, so 1 is all the way and 0.5 is only halfway. Camera panning is when we want to control where on the screen we want the tracked vehicle. For example, in one sequence, when showing the boost button, which takes up a lot of screen space, we move the camera up so that button can fit. For the background, we use the parallax effect. A background parallax effect is created by having multiple layers of an image. And when moving that image, the different layers are moved with different speeds. Layers that are supposed to be more far away are moved slower, and the layers in front are moved faster. So this creates an effect that some objects are closer than others in 2D. In Spine, you can create events at different positions in your animation, so these events can be intercepted by code to do something. In our case, it was good for getting sound triggers or playing special effects. It's easy to do, just load the Spine animation and attach a listener for that event. This design solution was made possible only by the fact that the developer and animator was teamed up. At first, we only had a rough idea of the design, and that grew along the way. Many details had to be fixed while we were in the middle of development. In the end, this was a real feat by the animators, which had to be really technical, and they created almost 100 different animations for that game. We had some problems along the way also. So one thing we struggled with was making the transition from one part to another really smooth. We didn't want it to be visible in any way that the track was made up of different parts. The animator had to position the vehicle of the animation, end of animation and beginning of the next animation exactly at the same spot. To make the transition smooth, we had to change the Spine animations to use a fixed time step. By default, Spine animations uses a variable time step. A variable time step means that depending on the time elapsed since last frame, the animation is updated accordingly. A variable time step can fluctuate between frames depending on what your machine is doing at the time. The alternative to a variable time step is called a fixed time step. With a fixed time step, the elapsed time between frames is not used. Instead, each animation or simulation is updated with a fixed amount. You get reliable updates each frame. To be able to hide the transition part from one part to another, it isn't enough to use a fixed time by itself. But with the help of using fixed time step, we could use a trick. When we have reliable updates, we know when an animation is about to end, and we want to know it the frame before it's actually ending. So to create a smooth transition between parts, we have to end the current animation early and start a bit into the next animation. Animations was tightly integrated with game logic, and because of that, they could introduce game-breaking bugs. Events could have the wrong name or being fired at the wrong time. So after any change to the animation, we had to carefully test everything again, and that was very many times. And sometimes the Spine tool was kind of buggy when handling the amount of keyframes and events that each of our animations had. I'll show you what it looks like. Something wrong with sound here. I don't know if we can fix it. That was it. Thank you.